Chapter 11, all about strings. Now that we have studied the array and the string type, it's time to see how the string data type for what it really is, an array of characters. In this chapter, we will look at some of the standard string functions that most languages provide. We will practice calling those functions so that we can understand what they can do for us. In this chapter, the string as an array, concatenation, the plus sign as an overloaded operator, the plus sign as an overloaded operator, a preview of objects, length and substring, find and charat, the brace set as an overloaded operators. The brace set as overloaded operators. The string as an array. I bet you did not figure that the string would appear as an array. It is ideally suited to be an array structure because it is a group of one type, a group of characters. Look at the word hello. These 5 letters could be each of the 5 slots of an array of characters. Let's call the array my word. Char, my word, 5. Now let's assign each of those slots manually rather than through a loop. My word equals H. My word 1 equals E. My word 2 equals L. My word 3 equals L. My word 4 equals O. Recall that we have to use the 0 index in C++ for the first slot in the array. Alternatively, we could declare my word as a string. String my word equals hello. That was a lot easier. The only problem with the string declaration is that you lose the understanding of what is really going on when you work with strings in a programming language. In the next few sections, we will look at the typical string function and practice using them in examples. After this, you will be happy to use the string type and let the computer do all the work. But I think you will appreciate how these functions work since they operate on an array. The first thing we will do is concatenate 2 strings, that is, add 2 strings together. Watch how this is done. String my word equals hello, string name equals James, string greeting equals my word plus name. If we look at each of the strings as an array, if we look at the strings as arrays, this is what they look like. See figure 11.1. Figure 11.1. Each of the strings is viewed as an array, and the array greeting is seen as a composite of the other 2 strings. My word 0, my word 1, my word 2, my word 3, my word 4. Name 0, name 1, name 2, name 3, name 4. Greeting 0, greeting 1, greeting 2, greeting 0, greeting 0, greeting 1, greeting 2, greeting 3, greeting 4, greeting 5, greeting 6, greeting 7, greeting 8, greeting 9. My word is HELLO. Name is JAMES. The greeting line is HELLOJEMES. You should also notice that greeting does not insert any space between the other two words. Greeting contains hello, James. If we want to add an intervening space we need to explicitly add it, as in this example. Greeting equals my word plus quotation marks plus name. The addition operator has been programmed to add two strings as well as two numbers. We say that this operator has been overloaded to do this additional operation. That means the language has two built-in functions for the addition sign. One that works for numbers being added and another that works for strings or characters being added. When the types of the arguments on either side of the addition sign are read, the appropriate function for the addition sign is executed. As you advance in your programming skills, you can learn how to write your own overloaded operators. Remember that the computer will know which function to use. It will use the one that corresponds to the data types that match it. See Figure 11.2. Figure 11.2. A plus sign is shown with arguments on either side of it. Depending on the arguments present, the appropriate function will be used. The addition sign goes to 4 and 8. Choose regular addition function. Goes to 12. Hello plus James. Goes to choose other addition function. Goes to hello James. The workload that the plus sign normally has is to add two numbers. To overload it is to add another job to its workload, that of concatenation. Here is another example of concatenation. String sentence equals my plus name plus is plus John. Notice that I added a space before each word so that the string will look good when it is printed. See out, sentence, and L. My name is John. String function. In this section, we will use some of the typical string functions in C++, length, substring, and find. Length is a useful function because it tells you how long your string is. Of course, you could just count the letters in the word, assuming it is not user input, and you would have the answer. But strings behave a little differently than the arrays. There is often a special character called a null character, which is put on the end of the string. I think of it as a stop sign, keeping the programmer from looking for any other letters in the string. Consider Figure 11.3, where one part shows an array loaded with characters, and the other shows a string with the same characters, but also with the appended null characters. Figure 11.3. Both strings appear as arrays, but the string on the right shows the terminating null character. Left string, THE blank CAT blank IS blank FAT dot. Right string, THE blank CAT blank IS blank FAT period null. Length and substring. Most languages have some kind of length function that returns the number of letters, including any other characters like blanks, punctuation, and so on. Since you learned about the functions in Chapter 8, we can practice calling that function. Except for some early languages, like Pascal, strings are treated as objects in C++ and Java. Although you will read about objects in chapter 15, we will have to make some minor adjustments in the way we call functions. With regular functions, you make a call by matching the parameter list with the appropriate types in your call. Consider the following example. The heading of a length function could be as follows: int length string m. So in order to call the length function, we would need to send in the appropriate parameter, a string argument. Here would be the call to the function. int m equals length greeting. Notice that greeting was passed into the function so that length could work on it to find the length. Objects use a different way of calling a function, and this is how it would look. String greeting equals hello James. Cout greeting length. Notice that the greeting, the object, is followed by the function name, rather than being contained in the parentheses. That is the main difference in the call. So let's practice calling the length function again. String first string equals my cat. String second string equals really cool. String third string equals first string plus second string. Cout first string length quotation marks second string length end line. Cout third string length 10 followed by 12, then 22 on the next line are printed. Remember to count the blanks and punctuation. Once you know the function heading and more about object syntax, you can easily call other string functions that the language has. However, we will delay calls made by objects until we learn more about objects. So all of the functions that follow have different headings from the exact ones you find for the string object. However, the most important thing for you to understand is what each function does. Following is an example of a string function that can be useful. Substring. A substring function will return a section of the string depending on what parameters are provided. Taking a subsection of a string is called extracting from the string. Here are some typical substring headings. Note: this code is for illustrative purposes so that you will know about the kinds of string functions you can call. However, you have not learned all of the grammar of C++, so I am presenting them in this way so that you can understand string functions, even though we are not ready to look at the actual code in C++. Warning: not standard C++ code. String substring string m int start string substring string m int start int length. string substring, string m, int start, int first ignored. Notice that both functions have the same name, but their parameters differ. This is another example of overloading, specifically function overloading. Here we are overloading a given function rather than the arithmetic operator. There are a couple of ways the extraction works. The first way is to take the string and find the first position where you want to start your new string, and then you extract everything from both including and after that position. This is pretty easy to do. Let's put objects aside for the moment and look at the following example where we call the first function. Warning, not standard C++ code. String m equals headhunter. String result equals substring m. 4. Result will contain hunter, since the h of hunter is in the fourth slot of the array. Recall that all arrays in C++ begin with slot 0. String word equals substring m6. Word will contain ter, since t is in slot 6. In the second example, there are two parameters besides the string m, the start and the length. This function behaves a little differently from the previous substring function. The start position still refers to the place where the extraction should begin, but length tells how long that new string should be from the starting place. Here are a couple of examples to demonstrate how this substring function works. Warning, not standard C++ code. String m equals headhunter. String result equals substring m for 4. Result will contain hunt, since the starting position is 4, followed by the length of 4, meaning 4 characters are stored in the new string. In another example, let's extract the first part of headhunter, namely the string head. This is how we would do that. Warning, not standard C++ code. String m equals headhunter. String result equals substring m04. Since 0 is the starting position, we extract the h at the beginning and show 4 characters. You can even extract a string of 1 character. Look at this example. Warning, not standard C++ code. String m equals headhunter. String result equals substring m31. Since the third slot is the letter D, followed by a length of 1, we extract only the letter D. The third function has 2 parameters in addition to the string. The third parameter, instead of indicating the length of the newly extracted string, indicates the first slot that will not be part of the extraction. That's a mouthful. Let's look at an example to clarify how this works. Warning, not standard C++ code. String m is equal to headhunter. String result equals substring m48. Since 4 is the starting position, we extract from slot 4 through slot 7 because 8 is the first slot we wish to exclude. Result will contain hunt. Here's another extraction using this same substring function. Warning, not standard C++ code. String m equals headhunter. String result equals substring m2 9. Since 2 is the starting position, we extract from slot 2 through slot 8 because 9 is the first slot we wish to exclude. Result will contain add hunt. Strings are objects in C++, so it is easier to wait until you learn something about objects to address how the syntax changes. Find and char wrap. Just like the previous function, we can't really use the precise C++ code to call them, but at least we can look at what each of these functions does. The find function will take a string, call it first string, and look for the occurrence of another string, called other string, within it. If it finds other string within the first string, it will return the slot, the index, where that string begins. If it does not find the string, it will return my -1. Look at this typical find function heading. Warning, not standard C++ code. int find string first string, string other string. Let's look at an example to see how it works. Warning, not standard C++ code. String first string equals foolhardy. String other string equals hard. Int x equals find first string other string. Cout x and l. 4 will be printed on the screen. In another example, let's pass in a string that is not in first string. Warning, not standard C++ code. String first string equals foolhardy. String other string equals day. Int x find first string other string. Cout x and l. -1 will be printed on the screen. Obviously, day is not contained in the word foolhardy, so the -1 passed into the x is clearly not an index value, since those values begin at 0. Note, -1 is a typical value used to indicate that something unusual has happened to an array and likewise a string. Arrays usually start with the 0 index and continue through the positive numbers. The -1 as a return value is a clever way of signaling that a problem has occurred. String functions are very precise. Words like day and day, little lowercase letter and uppercase letter, will not be considered the same because of the difference in the d's, nor will day be found within day, little d, upper d. Char at is a simple function that allows you to extract a character from a string. It behaves like the substring function, where the length is always 1. Let's look at an example. Warning, not standard C++ code. String m equals foolhardy. Char letter equals char at m6. Cout letter and line. R will be printed on the screen. Char at is easier to use than the substring function we used previously. Even easier to use is the following overloaded operator, the brace set. The brace set operator. The last function we will examine is the brace set, which works directly on a string. The brace set represents another overloaded operator. We have seen the brace set before in accessing array elements, list 5 for example. By overloading this operator, we are making the string as accessible as the arrays we studied. Look at how simple it is to use. Warning: not standard C++ code. String m equals foolhardy. See out M5 end line. The letter A will be printed on the screen. Here's a better example of the braces at work. Warning: not standard C++ code. String m equals foolhardy. String other string equals hard. For x equals 0, x is less than m, length x plus plus. See out mx and l. Each letter is printed on a separate line. Of course, it is easier to just print out a string all at once, but the brace operator allows you to treat the string like the array type. Summary: the string is like an array of characters. In any language, there are string functions available to you. In C++ and Java, the string is an object, so objects call functions differently from the way we have studied function calls. We examined typical string functions like length, substring, find, chart at, and two overloaded operators, plus and the brackets. The addition allows two strings to be combined or concatenated. The substring function extracts a string from another string. Length will find the length of the string. This is the number of characters in the string, including any blanks or punctuation. Find allows you to find the first occurrence of one string within another. If the string is not found, a value like -1 will be returned. Chart at extracts a single character from a string. Finally, the brace set allows the string to be manipulated in the same way as an array.